Hello everybody, this is Manas Bam and today I'm going to be sharing the first video of my machine learning tutorial series. So in this video I want to cover what is linear regression and how it is useful basically, and then how we can basically minimize the loss and optimize our weights. So all of that might seem a little unclear right now, but once we head through the tutorial you will see, you will start to understand everything. So today's topic is linear regression, right? So in machine learning, what machine learning is basically you have your features, or what they say, like okay, let me just give you an example. So if you have to predict the weather for tomorrow, so what all features or what all attributes can you take into account so that you can predict an accurate weather for tomorrow? So if I ask you that, you might probably say humidity, rain conditions, then like sunny, overcast, and many other options. So those are your features, right? So X denotes features, and then label is your Y, which denotes the labels. This is your the actual weather, right? So this can be rainy, sunny, humidity, wind speed, and there can be lot many more. Whereas your labels is only going to be one, the temperature, right? The temperature for tomorrow. So either it can be a range or something, but the labels is Y, that's your temperature in this example. So usually in machine learning you will have X and Y, and you will have X and Y, and then what your job is to learn out of that X and Y and to predict on a new Y. So to give an concrete example, let's just say you have a bunch of X and Y values. Okay, X, Y. Let's say you're just trying to predict whether it's what's the temperature given some quantity, some percentage of humidity. Okay, so X can be like percentage of humidity. Let's say 5%, and it's like a 5 degrees, or I don't know, I'm just picking random numbers right now. 7, 9, 10, 11, and probably 3, 5. So so X, this can be like the humidity percent, and Y can be your temperature, right? This is your prediction. Temperature. Okay, so now let's plot this in a graph. Okay, where this is our x-axis, our y-axis. So X, let me just 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 10 11 12. So the first point is 5 comma 5, so about there. Then second point is 6 comma 7, about there. Third point is 7 comma 9, about there. 10 comma 11, about there. And then 3 comma 5, let's just change this to like 3 comma 2. Okay, 3 comma 2, about there. So now these are our like few examples that the user has given us. He's telling us, hey computer, when the humidity percent was 5, the temperature was 5 degrees. When the humidity percent was 6, the temperature was 7 degrees. When the humidity percent was 7, it was 9. When it was 10, it was 11. And when it was 3, it was 2. He can also, probably there might be some more data that might have points like this, right? Like one of them could be 6 comma 8, right? That could be one possibility also. So now what our job is to fit a line through this data. So to fit a line, if I ask you, you would probably draw some line like that, right? There's some increasing, so the line seems to be increasing. So if I have more humidity, there's more temperature. That's what the data is trying to tell us. but how much, right? So if I have a new data point, let's say 12, we need to be able to calculate what is the temperature at that day, what is this y. So that's our main job. Given this x, we need to predict this y, and that's the whole basis of machine learning. And in this tutorial, like I said, I was going to discuss about linear regression. So I just explained to you that we have our x and y points. X, let's like 2 2 3 3 5, I don't know, some random points, and our job was to make to fit this line through the data, so that any new point, see, we don't have 12 over here, right? But if I ask you, okay, I've given you 12, I want you to tell me what is the temperature. So that can be a task that you can ask the machine, and it should be able to tell you if we are able to fit a good model through this data. So that's the main task that we're gonna try to do today. So that's linear regression. And now I want to discuss about the loss function for linear regression. So 1 second, can we move down? Oh, we can. Oops. Okay, so the loss function, right, that's what we're going to discuss now. So the same thing, let's say these are a few of our points, and we plotted that line. Now how do we measure that how good our line is, or how best fit our line is, right? So let's say the x was 2, and the actual y value, this point, right, this point is 2 over here, and this point's actual y value is, let's say, 5. But what is our model predicted, right? What is our model predicted? Something over there, right? So that can probably be 4. So now we need to measure the difference between these two values, 5 and 4. And what's the difference? Well, it's 1. So if I consider, let's say this point, right, this is, let's say, y, the actual y or the true y, and this point over here is the label, this is the label, and this is our predicted value. Let's call this y hat. So how do we measure the difference between these two? Well, simple, y minus y hat, right? That's the difference. But now I'm going to ask you a question, and please just see if you can answer it before you actually see the solution. If this is our predicted value, right, because it's on the line, and let's say this was some point whose actual y value was, let's say, 7, and our machine predicted 9, right? So if I ask you what's the difference between these two, what would you say? Would you still say it is y minus y hat, whereas where this is y and this is y hat? Question. So think. Okay, now I'm going to tell you the solution. It cannot be. See, y is 7 and y hat is 9. So 7 minus 9 will give you minus 2. But you can never have minus 2 as an error, right? It's like saying I go to an exam which has the maximum marks 100, and I get 102 in the exam. That can't be possible. Same way, the lowest value for error can be 0. But it can never be negative. Error can be positive, it can be 0, it can never be negative. So what do we do because we've encountered this problem? All we need to do is square this, right? If we square this value, y minus y hat, this minus this, we just get a positive value. And there are other ways in statistics that tell us why we need to square it, but I'm not going to discuss that right now. But just keep in mind that because we need a positive value for an error, we are squaring the term. And then what we do is we take the mean. By mean, I just multiply this by 1 over the number of points that you have. So 1, 2, 3, 4, whatever, 5, 6, 7, 8. Let's say we have 100 points. 1, 2, 3, 4, 5, 6, 7, 8, about 100 points. So this will be 1 divided by 100 into the sum of these differences squared, right? So I'm just going to write down the proper cost function right now so that you can understand better. Sum of I, okay, equals 0, I equals n. Sorry, this is going to be 1. I equals 1 through I equals n. number of points, and 1 divided by number of points into y of I minus y of I hat the whole square. Now let me explain this. So I is, let's say, 1. So let's say the first training point, this one right here, this one, right? What are we doing? We're saying, okay, this is the first training point. Take the actual y value, which is this. Then take the predicted, so this is the actual y value, this is the predicted y value, this is the predictive y value. We take the difference and then we square it so that we get a positive value. Then let's say that thing gave us some value a, right? Then I moves on to 2. Okay, so let's say this was our second training point. This is second training point. This minus this thing whole square will give us b, and we keep adding b because we're doing the sigma operation. We keep adding all the sum of the differences squared, right? Sum of the differences squared. So hopefully that was clear. If you have any questions regarding the loss function, please post it in the comment section. I will definitely answer it. But hopefully that was clear, and the loss function is done. Now we need to make a representation of this line. Okay, so what I mean is, if I ask you the formula of a line, you will say that any point y is equal to m times x plus b, right? So if I have a point, let's say x equal to 2, where m is the slope of the line, right? So at this point over here, the slope is positive. For this line AB, slope is negative. For line CD, slope is positive. And B is the bias or the y-intercept. So if I extend this line, I see, probably y cuts this line cuts the y-axis at, I don't know, 2. So that's basically this value B. M is the slope, and B is the y-intercept. So the slope, just a simple trick how to get the slope is, any 2 points between in this line, if I take the difference between y and divided by the difference between x, I get the slope of this line. So all we need to do is find the formula of this line, right? Once we have the formula of this line, it should be a piece of cake to draw this line through the data and predict on any new x value. Even I can give you 13 and ask you, where does 13 lie? Probably somewhere there. I don't know, something like that, right? So we have this representation of our line, right? Y equals mx plus b. So now x, y, let's say this was our line, this was our few points. We need to find out m and b, because remember, x will be inputted by the user, right? X will be inputted by the user, and that's when we need to make a prediction y, right? But for that, what else do we need? We need b and we need m, right? So how do we find out these m and b? Well, first off, in machine learning, you initialize it randomly. So m can be random like 0 and b can be random like 0. So what's your line going to look like? It's going to just look like this. At any point of x, y is going to be 0. This is going to be a line, right? Any point of x, m and b both are 0. So y is also going to be 0. Any point of x. But we need to find m and b that makes this line, right? CD. This line, CD, that great line that best fits our data. And for that, we have something called an optimizer, which I will be discussing in the next video.